Hello everybody, and since we didn't get our notebooks until February 14th, Valentine's Day, I want to kind of go through and throw some of the notes together for these different skills that we have. Now, as you're reading the notebook, the things that are typed at the top are skills that you need in order to master this class. Which means, for this one, classifying polygons by their sides and angles, number of sides, convex, concave, regular, irregular, etc., etc., etc. Alright, so just really quickly, we'll go by number of sides, and we'll go with names. And we'll start with that. So we have names. Now, a polygon must first off be closed. And by closed, I mean this. There's no way to get in or out. An open polygon is like this. So this is open, and this is closed. So every polygon we deal with is going to be closed. So 3 sides, closed. This is your triangle. 4 is your quadrilateral. 5 is a pentagon. 6 is a hexagon. 7 is a heptagon. 8 is an octagon. 9 is a nonagon. 10, deca, like decade, a decagon. 11, no name. We just call it an 11gon. 12, a dodecagon. And for any side n, we call it an n-sided gon. Like, for example, if n was equal to 14, we called it a 14, not 114, a 14-sided polygon. Or a 14gon. It gets the idea. Alright, so, number of sides, we got our names. Now, next up, convex versus concave. And the best way to describe these is to show you different ones. A convex polygon looks like this. A concave polygon looks like this. Now, the strict math definition says if you extend any side of the polygon and the side never comes in contact with the interior of the polygon itself, just like here, then it's convex. And so basically the sides are the borders for that. For this, we extend this side right here, it intersects right there. So it intersects the interior. So therefore, it's convex. Those are the big differences. So, extend a side. If an extended side intersects the interior, of the polygon, it is not convex, it is concave. And you can kind of think of, there's a cave in here. Normally, a pentagon, since we have 1, 2, 3, 4, 5, normally a pentagon will kind of look like this. But this part, bam, came down to here. And instead of going out to here and going out to there, it fell in. It caved in a little. So you have your cave in. And over here, if we extended this side through as well, over here is going to make it concave as well. So be careful when you're looking at these, whether we're dealing with convex or concave. We deal mostly with concave. No, that's not true. Mostly we deal with convex. We deal with convex. And lastly, for this first page, regular versus irregular. This is one of my favorite definitions of all math. A regular, let's kind of move this up here. A regular polygon, all sides are congruent, all angles are congruent, and this means interior angles and exterior angles. An example, not the best example, the equilateral triangle. That's 60 degrees, that's 60 degrees. I didn't draw it perfectly, but close enough for government work. You extend out with auxiliary lines. This would be 120 degrees. This one, 120. This one, 120. So all the interior angles are congruent, all the exterior angles are congruent. And you will find that for every single polygon. There is a regular polygon for every single one. Irregular polygons, they're not regular. Which means not all sides are equal. Not all sides are congruent. Not all angles are congruent. Not all exterior angles are congruent. So, think of a rectangle. All the angles are congruent, but the sides aren't. So it's irregular, even though it has a couple of the characteristics of the regular shapes. Some special ones, the equilateral triangle and the square are regular. And then you get into regular pentagons, you'll get into regular other shapes as well. So that's just a quick definition for those three different parts of this.